morning students. Last two class we studied the electric field produced by a dipole in an axial line as well as in an equatorial line. Then in this class we will study what is the impact that is produced on a dipole when it is placed in an electric field. So the first question, the electric dipole in an uniform electric field. So in this diagram a uniform electric field acts like this. This is the direction of the uniform electric field. If it is denoted like this, then surely there is a plus q charge. Here there is a minus q charge. The reason is the electric lines of force starts from plus q to minus q. So this is the uniform electric field. In this uniform electric field, I am going to consider a dipole minus q and plus q are placed at a point A and B, and it makes an angle theta with an electric field. Then O is the midpoint of the electric dipole, and distance between O midpoint of the dipole to the charge is L. In this diagram it is denoted as A. You can use L or A, that is not a problem. Okay, then what is torque that we should understand? The force of magnitude. Before that, when a charge q and minus q plus q and minus q is placed in a uniform electric field, that experience certain force. That force is calculated because we know the electric field intensity formula, E is equal to F by Q. Then what is the formula for F, force experienced by the charge? F is equal to EQ. This is the force experienced by charge. If it is a minus charge, you put minus sign here. If it is a plus charge, just put a plus QE. Then minus Q charge experience the force of minus QE. Plus Q charge experience the force of plus QE. Then the net force acting on a charge will be F is equal to F minus Q plus F plus Q. That is force due to minus q charge and force due to minus plus q charge. Then we know the value for force due to minus q charge, that is minus QE, and force due to the plus q charge is plus QE. They cancel each other, so that's 0. So what is the thing we understand? The net force acting on a dipole is 0. Now what is the torque that is experienced by the dipole? A force of magnitude PE acts opposite to each other, so hence the net force acting on a dipole is 0. That is what I told you. The net force acting on a external uniform electric field is 0. It will be asked in 1 mark. Next, however, the force are along the different lines of action and constitute a couple. Hence the dipole will rotate and experience torque. When a dipole is placed in a uniform electric field, it starts rotate. So rotate in the sense it is turning, so that is called a torque. Then torque is equal to a force into perpendicular distance. Here it is a perpendicular symbol is there, perpendicular distance. What is perpendicular distance? The distance between the two charges. A perpendicular distance between the two charges is known as perpendicular distance. How will you calculate the perpendicular distance? Let's say this is point A, this is point B, this is point C. Here A and B are the two charges, minus Q and plus Q charges, and BC is the perpendicular distance, and it makes an angle theta with an electric field. Then look at this triangle. It looks, in this triangle AB is called hypotenuse. Okay, then BC is the opposite side of the theta and AC is the adjacent side of the theta. So here it is, in which let me calculate what is the value of sin theta. Sin theta equal to, what's the formula for sin theta? Adjacent by opposite by hypotenuse. Correct. What is the opposite side of this theta? This is opposite side. Opposite side is let's say this is point C, then BC divided by hypotenuse is AB. Then what is the total value of AB? Is 2A. So let me write this AB as 2A, so that sin theta is equal to BC divided by 2A. I want to calculate BC. then BC is equal to 2a 2a sin theta. So BC is the perpendicular distance. BC is the perpendicular distance. So I calculated perpendicular distance. Then force due to the charge, that is also I know, plus QE or minus QE. I can take any one of the force. Okay. Then let me substitute the value of force in a torque formula. What is the formula for force I studied? Let me take plus Q charge force, that is QE is the plus Q charge force, and 2L sin theta is the perpendicular distance. See that here they used L notation, but here A is there. I told you the notation can be used, any notation can be used. So here also if you want you can put A, or if you change this A as a L. Okay. Then the torque is QE 2L sin theta. In this formula we know the electric dipole moment formula. P is equal to, what is electric dipole moment? It's a product of magnitude of one of the charge into distance between the charges, that is Q into 2L. Here Q is here and 2L is there. Then I can replace this Q into 2L as P, electric dipole moment. So the formula will be torque is equal to PE sin theta. In vector notation, tau vector, see it is looks like T, correct? It's not like T. The tau should be written like this. Okay. Then torque, tau is equal to P vector cross E vector. It's a cross product because the product comes in sin theta. Okay. Then the direction of the torque is perpendicular and into the plane of the dipole moment and an electric field. Then the SI unit for torque is, see that the electric force is there. What is the SI unit for force? Newton. SI unit for force is Newton. The distance is measured in terms of meter, so that the SI unit of torque is Newton meter. Now let me draw the dipole moment and electric field and torque directions. If this is the direction of electric field, and P is the direction of the dipole moment, then they separated, that is electric field and dipole moments are separated by the theta, angle theta. Then the torque will be acting perpendicular to the plane of electric field and dipole moment. Then in this we can derive three special cases. One is, what will happen when a dipole moment, that is P and E, are in same direction, so that the theta will becomes 0 between them. So first case, if theta is equal to 0 degree, then torque will become 0, because sin 0 is equal to 0. So the value of torque will be 0, so that the dipole do not experience any torque when it is placed in a uniform electric field in along the same direction or parallel to the uniform electric field. Then what will happen when a dipole is placed perpendicular to the uniform electric field, that is the theta will becomes 90 degree. When theta is equal to 90 degree, sin 90 degree is equal to 1. That is a maximum torque experienced by the dipole when it is placed in a uniform electric field. It happens only when 90 degree. See, remember this is a hint to solve the problems. Many problems they'll ask you to find the torque, maximum torque, that's it. They won't give the angle between the electric field and the dipole moment. Okay, if you remember this, the maximum torque up, it means that the angle is 90 degree. So when theta is equal to 90 degree, the torque will be maximum, that is PE. Then what happens if the dipole is placed parallel but in opposite direction to the first case, that is the theta is equal to 180 degree, then also the torque will be 0. So this is the torque experienced by the dipole in a uniform electric field. It's a 3-mark question. Okay, is that clear? Next we will go torque on an electric dipole in non-uniform electric field. In the first case, we studied electric field due to torque experienced by the dipole in a uniform electric field. There I told you the net force is 0, but torque will be there. Okay, so net force 0, torque is maximum when it is placed perpendicular to the uniform electric field. In 1 mark they'll ask you what is the torque and net force of the dipole when it is placed parallel to the uniform electric field. See, there is a twist in this question. What is the torque that is experienced by the dipole when it is placed parallel to the uniform electric? Parallel in the sense theta is equal to 0 degree. Theta is equal to 0 degree. Theta is equal to 0 degree. So theta equal to 0 degree in the sense the torque is also 0 and net force is also 0. This is for one case. And another case, the question will be like this: what is the net force and torque experienced by the dipole when it is placed perpendicular to the uniform electric field? So far I am talking about only uniform electric field. I did not enter into non-uniform electric field. Okay, then when a dipole is placed perpendicular to the uniform electric field, that is theta equal to 90 degree, then torque will be maximum and force will be 0. So this is a 1 mark. It's a one separately they can be asked in one. It can be asked in 1 mark. Now what will happen when a dipole is placed in a non-uniform electric field? When a dipole is placed in a non-uniform electric field, that means the field is not uniform. It will be acting randomly. When the dipole is placed in a non-uniform electric field, then the force experienced by the plus q charge will be different and force experienced by the negative charge will be different, so that the sum of the force, we know that they are acting opposite, but since they have a different values, they will not be 0, so there will be a force. So net force will not be 0 in this case. Then see that this is a diagram in which the direction of the electric field is not a uniform, so it is called non-uniform electric field. If dipole is placed in a non-uniform electric field, there is the net force as well as net torque. Both the force and torque will be experienced in a non-uniform electric field. That is the another thing. It's a important question. What is the torque experienced by dipole in a uniform and non-uniform electric field? The next one 2 mark question. We all use this, most of us use this microwave oven, mostly in bakeries. For what purpose they use this? It is used for cooking the food. Then how does it work? What is the working principle of microwave oven? So the microwave oven, it's a microwave oven. In a microwave oven works in the principle of torque acting on an electric dipole. In a first class I told you, in a dipole first class I told you, an example for electric dipole is water, H2O. See, if you want to prepare food, surely there will be water molecules, correct? So water molecules are a dipole. When a dipole, this water molecule is placed in a electric field, so electric field will be produced in a oven, micro oven. In a micro oven, electric field will be produced. In a electric field, where the water molecule in a food which act as a permanent electric dipole. When oven produces microwaves which are oscillating, which produce electromagnetic field, oscillating electromagnetic field, so water molecules will experience torque. So that torque in the sense what? They started oscillating like this. It goes down and it goes up. So it start oscillating like this. When it is oscillating, the bond between hydrogen and oxygen will broke. When the bonds are broken, the heat energy will be produced. That heat energy, thermal energy, used to cook the food. Due to this torque on each water molecule, the water molecule rotate very fast and produce thermal energy. This is he used to cook the food in a faster time. Okay, this is how the microwave oven works. Is that clear? It's a 2-mark question. Explain the working principle of microwave oven. What will happen in a microwave oven? A non-uniform electric field will be produced, and the shield is a uh, the outer layer is acts as a shield, so that the electromagnetic waves do not escape from the shield. So the produced electromagnetic waves, that is microwaves, will be moved to and fro between the walls of the microwave oven. Okay, this is what microwave oven. The next one, an problem based on this electric dipole in a uniform electric field. A question problem will be asked in 2 mark. So some example problem is a sample of HCl gas is placed in a uniform electric field. Look at that. This question is deals with uniform electric field. Uniform electric field, and it has a magnitude. So E value is given, magnitude 3 into 10 to the power 4 Newton Coulomb power minus 1. The dipole moment of each HCl molecule is, so dipole moment in the sense P is given, that is 3.4 into 10 to the power minus 30 Coulomb meter. Not it is centimeter, it is a Coulomb meter. See that the C is capital letter. Calculate the maximum torque experienced by the HCl molecule. See that there is a hint is given, maximum torque. So what is maximum torque? When the dipole will be experiencing the maximum torque when theta is equal to 90 degree. That is what I told you previously. When theta is equal to 90 degree, then the torque will be maximum. Then the maximum torque experience solution, the maximum torque experienced by the dipole is when it is aligned perpendicular, when it is aligned perpendicular to the applied field. So when it is aligned perpendicular field, then the formula will be PE sin theta. The theta value is 90 degree. Sin 90 degree is equal to 1. Then P is the dipole moment, which is given here. Dipole moment value is given here, 3.4 into 10 to the power minus 30 Coulomb meter, and electric field value is given 3 into 10 to the power 4 Newton per Coulomb. Substitute the value and multiply that, and you will get the maximum torque experienced by the HCl molecule in a uniform electric field of magnitude 3 into 10 to the power 4 is 10.2 into 10 to the power minus 26 Newton meter. So it will be asked in 2 mark or directly in 1 mark. Okay, if it comes in 1 mark, simple multiplication, 2 1 2, the values will be simple multiplication numbers. As well as there will be a twist in this question. What they say, instead of maximum torque, they'll say what is the instead of this, they can ask this, they can ask like this: when the dipole or when HCl molecule is aligned parallel to the uniform electric field, then what is the torque experienced by each HCl molecule? They won't give this maximum. So instead of that, they'll give you what will happen when a dipole is placed parallel to the uniform electric field. Then the theta will become 0. Then there won't be a torque, so torque will be 0. So this is what this question, this problem. Okay, in this class we started discussing electric field. What happens, a dipole is placed in a uniform electric field. I told you the net force is 0, but there will be a torque. Then the formula for torque is force into perpendicular distance, that is F is equal to tau is equal to QE 2L sin theta. That is what we studied. Then the final formula for torque is P in P cross E. Okay, Then there are three special cases. When theta is equal to 0 degree, then the torque is equal to 0. When theta is equal to 90 degree, then torque is equal to pe, that is a maximum value. When theta is equal to 180 degree, that is when how the dipole is aligned to the electric field, then the torque is, the different values of torque is given. Then next we studied what happens when it is placed on a non-uniform electric field. I told you each charges will experience different force, that so that the net force will be a there will be some value for the net force, though, so it will not be zero. In a non-uniform electric field, the dipole experience both torque as well as net force. Okay. Then we studied microwave oven, working principle of microwave oven. This, what is the principle of microwave oven? Torque experienced by the dipole, that is the principle of torque experienced by the dipole in a uniform electric, or in an electric field, in an electric field, that is the principle of microwave one. That is what we studied. Next we solved one problem. In next class we will continue with the next topic, and thank you.